Good evening, Bachcho. Welcome back to my channel Physics Fund. We are going to solve some typical problems on center of mass. So today I have selected a problem. What is the problem? Find the position of center of mass of the section shown in the figure. The section shown in the figure. The total sphere has the area of the 2A, then the center of it is A, comma A. Now that portion is scooped out from the whole of the square. Now to find the center of it is, this is A, okay, and this is A by 2. So the total is A plus A by 2. That is equals to 3A by 2. That is equals to X. Now, for the, let us consider this is X2. Now, for the Y2, it will be the same, 3A by 2. And here, the X1 is equals to A and Y1 equals to A. Now as it is scooped out, so the center of mass along the x-axis, XCOM, center of mass is equals to A1 x1 minus of A2 x2 by A1 minus A2. Now that is equals to A1 is the whole area, and what is the area of the square? 2A whole square into x1 is A, that is into A, minus A2 means this, whose side is A, so the area is A square, into whose center is 3A by 2 by 2A whole square minus S square. Now to calculate it, the next line is XCOM is equals to plus 2A whole square, that is 4A square into A minus S square into 3A by 2 underneath 4A square minus S square, that is 3S square. Now the next line, is 4AQ minus 3AQ by 2 by 3A square, that is equals to 8AQ minus 3AQ by 6S square, that is equals to 5AQ by 6S square, that is equals to 5 by 6A is the XCOM, that is the center of mass along the x-axis, and similarly for YCOM is equals to A1 Y1 minus A2 Y2 by A1 minus A2. Putting A1 A2 Y1 Y2 from the data given, we have the 5 by 6 A. Now what is the position of the center of mass of that laminar? Is 5 by 6A, 5 by 6A. That is the complete solution of that typical problem. To solve another typical problem, the density of a thin rod of length L varies with the distance x from one end as rho equals to rho 0 into x square by L square. Find the position of the center of mass. Find the position of the center of mass. Now, to solve it, first we have to think about the rod. Let us draw the rod. This is the rod. It is lying along the x-axis. This is y-axis. Now it is a rod. There should be an area of cross section. Area of cross section. Area of cross section is A. Let us consider the area of cross section is A. Now let us consider a thin part at a distance of x is dx. So dx. Now as the small thickness of the small portion is equals to dx, then the volume should be is equals to a dx. Now volume should be a dx. Now what is the density? Density is rho equals to rho 0 x square by L square. Then the mass dm of that small portion is a dx into rho. Now we are going to find the center of mass of the rod. Rho equals to rho 0 x square by L square. Now to find the XCOM center of mass is equals to integration x dm, limit is 0 to L. Now the integration 0 to L of dm. Now what is dm? dm is a dx into rho. Now that is equals to integration 0 to L dm x into a dx into rho by integration 0 to L dm means a dx into a rho. Now is equals to 0 to L x into a should be cancelled out from upper side and lower side, and dx is written as, and rho is equals to rho 0 x square by L square, and in that case 0 to L a cancel out, so dx into rho 0 x square by L square. From that rho 0 will be cancel out and L square should be cancel out because they are constant. Now x COM is equals to 0 to L x cube dx, x cube dx divided by 0 to L x square dx. This is x square dx. Now to integrate it, that is x to the power 4 by 4, that is L to the power 4 by 4, and here L cube by, that is 3, L cube by 3. So we have L cube, that is L, that is 3 will be reversed, that is 3L by 4. 3L by 4 is the position of the center of mass. Students, we are going to learn the motion of the center of mass. In the motion of the center of mass, we would learn about its velocity, acceleration, and what is the relation between the acceleration of the center of mass with the external force. So let's start the first one as the motion of center of mass. Center of mass. The motion of the center of mass. Here R is the position of the center of mass. R equals to summation of mi ri vector. I is equals to 1 to n by m. Now multiply the m with r. We have m r vector, that is equals to summation of I equals to 1 to n mi ri vector. Now differentiating both sides with respect to time, we have m dr vector by dt, that is equals to summation of I equals to 1 to n mi dri vector by dt. So that is equals to m into velocity of the center of mass v, that is equals to summation of I equals to 1 to n mi vi vector. Now again differentiating with respect to time, we have m dv vector by dt, that is equals to summation of I equals to 1 to n mi dvi vector by dt. So from here we have m into acceleration of the center of mass, capsule, we should consider it capsule, that is equals to summation of I equals to 1 to n mi ai vector. What is mi ai vector? That is the external force, that is equals to F external force. So from here we have the F external force is equals to m into a, that is mass into acceleration, and v is the velocity of the center of mass. We are moving towards the linear momentum of the system of particles. Linear momentum of the system of particles. From that linear momentum, of the system of particles. Of the system of particles. Here we have the mv is equals to summation of I equals to 1 to n mi vi vector. So here the linear momentum of the center of mass P is equals to mv equals to I equals to 1 to n mi vi. Now differentiating both sides with respect to time, क्या मिलेगा? That is dp by dt is equals to m dv vector by dt. What is this? This is the F external force applied on the center of mass. If the F external force is equals to 0, then we have dp vector equals to 0 into dt. Now integrating both sides, p vector is a constant. So here we have the linear momentum of the center of mass is constant whenever the external force is zero on the center of mass. So for the day, goodbye, stay tuned, please share, subscribe, like and comment. We always need your support to grow. Thank you.